Hello, everyone. So what we are going to be doing for our remote learning, I am going to be taking and making these videos going through some of our Ready, Set, Go problems, just like what I would in class. I'm not going to go through all of them, though, so you will have some to figure out on your own, just like you should. And with this, we're going to take, just like in class, we're going to go through. I'm going to do problems with you. We've done this before. Hopefully this won't be too bad. We're dealing with a lot of circles and transformations, so I'm hoping you'll be fairly comfortable with these things. If you don't have your workbook, because I know the majority of you had left them at school, I'm hoping most of them have been delivered to you guys, but if you did not end up getting your workbook over the time we were apart, then I will have a PDF available of the Ready, Set, Goes. It also will have all the lessons in there. You don't have to do the lessons, just the Ready, Set, Goes, but it will all be available for you to look at. If you have a printer, then by all means, print that, because then you can write right on it. Makes life a little easier. But if you don't have a printer, which is totally understandable, then go ahead. What you're going to do, and what any of you who don't have it are going to do, you're going to take and look at the document on the computer, and then on a separate sheet of paper, notebook paper, you're going to write what the lesson is. So in this case, we're doing 7.1. You can put 7.1 on the top. Then you'll write number 1, and you're going to give your answer. Now, on these first ones on this one, there's not really a lot of work, so you don't have to show work. On ones that involve work, I expect to see some work, okay? And then with your answers, if you only have an answer because there's not really any work to show, that's fine. Just write the answer. But on ones where you need to do some work to get to your answer, I want your answer to be boxed or circled or highlighted, something, so that way it's easier for me to find your answer. Because these are going to be submitted online, pictures of your work being submitted to me online, it's going to be a lot harder for me to search all over the page for where your answer is. So make it obvious with where your answer is. Otherwise, if I don't see it, it's wrong. You miss it, sorry. That's just how it's going to go. So like I was saying, how you're going to submit these things. So whether you have your workbook, whether you print out the PDF so you have all the pages, or whether you take and write it down on a separate sheet of paper, you're going to take a picture of one of those 3 documents, whatever you have that you're putting your answers on. You're going to take a picture of that. You're going to send it to me either on Canvas or via email. One of those 2 options, whichever one you're most comfortable with, will be fine with me. Just make sure you get it submitted to me. Otherwise, guess what? It's going in as a 0. Yes, you will be able to make things up, but it'll still go in as a 0 if it's not in by the due date. So keep that in mind. Let's see. Oh, when I'm doing these videos, guess what? You can't just do all the work and then not watch the video, because there's going to be a keyword you have to listen for within the video, and I will announce it. I'll say the keyword is, and then such and such, and then I'll repeat it a couple times throughout the video, but you're gonna have to watch the video to make sure you know what the keyword is, because that's going to be part of your grade, and it's going to be a decent amount to make sure you're watching these videos and to make sure that you are taking and working on this. So that's one way of me checking in on your work and how you are trying your best to succeed through these. So you will have to listen to these. Yes, I know, you'll get to listen to me, but guess what? You'll actually be able to hear me this time. So it'll hopefully be good. So like I said, we're taking and looking at 7.1 today. So what we're doing within this, if we look at the document here behind the video, we have, for each pre-image and image, determine the scale factor between the 2 figures. We've done scale factor before. We know what we're doing. So we look at this, and this first triangle here, triangle ABC, then we have A prime, B prime, C prime. So we're going from the smaller one to the larger one. So if we count, now, taking and counting these, you find a side that's either a horizontal or vertically perfectly on those grid lines. So we've got the side AC lines up perfect. So we've got 1, 2, 3, 4. This is a side of 4. The corresponding side is 1, 2, 3, 4, 5, 6, 7, 8. So how do we go from 4 to 8? We multiply by 2. There's your answer. So I will be trying to write with the lovely little pen tool within the PDF. It's a little complicated, so bear with me on my writing. It won't be the best, but hopefully you'll be able to understand it. And if you're listening, you'll definitely get the answer. So keep that in mind as we're going through this. All right, we'll do one more of this one. If we look at number 3, we are going from the smaller one once again to the larger one. For this one, notice we've got a circle and then we have sort of a triangle formed that's on top of it. So it looks like an ice cream cone, honestly. But we've got a lot of dimensions that we can't actually calculate. But we can find the length of BC. In the original, it is 2. In the new one, it is 4. So how do we go from 2 to 4? We multiply by 2. And yes, I know the 2 problems I decided to do with you are both multiplying by 2. So it's both a scale factor of 2. No, they aren't all 2. I will tell you that now. And remember, if you're going from a larger image to a smaller image, it's going to be a fraction. So keep that in mind as you're taking and doing these, okay? All right, so for the next part of this, let me just scroll, too far. Sorry about that. All right, for the next part of this, we have a pre-image, and the result below is from a dilation. Now, what we need to do is we're not figuring out what the scale factor is. Instead, we're trying to take and figure out what the center of dilation is. So from what point did we take and extend out our figure to get to the new one? So what's that center of dilation? So we've talked about center of dilation before. We've looked at how it works. Remember when we drew all those lines that went from the center of dilation through our original image and extended it out to get that new image? Guess what? That's what you're looking at now. You have to figure out what that point is. So before we had the point and either the pre-image or the image, and we had to find the opposite. Now we have both the pre-image and the image, but we need to find the center of dilation. So if we look at number 5 here, if we draw a line that goes from A prime through A and down, same thing with D prime to D and down, just extend it out. Remember, they're all going to intersect at some point. So I will attempt to draw this. Obviously, it's probably not going to be the straightest of lines, but I will give my best attempt. You guys can do a lot better than me. Use a ruler if you have one. So drawing this down, it's going to go right about there and then down. And then, oops, it's a little, hang on, curved it too much. This way. Okay, then our D prime down. Notice my lines are far from nice and straight, so keep that in mind. Mine will be a little bit rough, but I will tell you what the exact answer is as we finish this off. Now, the line that we have through D prime and D and down, it's going to be the same line for going through B prime and B, so we don't have to draw that a second time because they are on the same X coordinates, so it's all going to be through the same line. And so then we just have to finish out with C prime to C. Ooh, very curvy line, sorry. All right, so if we notice, where are all these lines intersecting with one another? They're all coming down to this point right here. So if we take and mark that point, what is that coordinate? If we look, we're right on, before I took and colored it all over, it was 5. So the ordered pair there is 5. Sorry, I know this is so time consuming to try and write with this. 5, 0, because we are right on the x-axis. So you will have an ordered pair for every single one of these answers. Don't just give me an x value or don't just give me a y value. You need to have the ordered pair because our center of dilation is a point on the coordinate plane, which means it's an ordered pair. All right, so same idea for 6 and 7. Take and draw lines that go through your different points. So make it so L and L prime go together, K and K prime. Same thing with this one. You want to draw the lines through them and extend them out so you can actually see where these things intersect. If you only draw them to connect, so like in this one, if I only went from A to A prime, we would never have found the point 50. You have to extend it past both the figures to figure out where it might be. Now, in this one, our point was outside of our figures. It's possible that your center of dilation can be the center or somewhere within the figure. So if it happens that everything intersects at some point inside your figure, sorry, can't talk, That's perfectly okay. Don't think that that's the wrong answer. That is completely possible. Center of dilations can be a variety of places, but it is always going to be true that the lines from your prime value and your original value, or your original value and your new value, they're going to line up perfectly. Okay? All right, the next section is more dealing with our centers and finding various centers. Oops. For this one, it's centers of rotation. So centers, all over the place. Hang on. So for centers of dilation, those were fairly easy because we just draw the lines. Centers of rotation involve a little bit more work. So when we're taking and doing a rotation, it depends on the degree. So that can make things difficult. But one way is to take and look at what you have and try to figure out what sort of degrees you could use. Now, we know we should be able to take and find a 90-degree rotation. So looking at this here, so you can always, between 2 points, figure out, okay, how can I make a perpendicular line that goes through those 2 points and then a line perpendicular to it. The intersection of those two lines would be what your center of rotation is. So keep that in mind. So on this one here, if we look, we have 1, 2, 3, 4. We're going down 4 and over 1, 2, 3, 4. So our slope, remember we marked that with an M, equals, sorry, I know this is hard to look at, -1, because -4 divided by 4 is going to give us that -1. Now, to do a perpendicular line, we find the opposite reciprocal. So if we take -1 over 1, because any whole number is always over 1, and we flip it, well, we're going to have 1 over -1, but then we change the sign, so it's just 1. So we have a new slope of 1. Now, we find the middle between these two. So how I do that is I go up and over. There's 1, up and over. That's perfectly the middle right there. So I'm going to mark that with a different color. So there is our center between these two. Now, this center right here, that's a possible point of rotation. It'd give you a 180-degree rotation because the 2 points would lie on the same line. Now, if we extend this line out using our +1 slope, any point along this very crooked line that I'm drawing right now, but you get the idea of it, any point along this line is a possible center of rotation. So for this, you need to list 4 possible centers of rotation. So yes, hang on. So yes, I do expect you to have 4. If you have 3, you're getting marked off. If you have 2, you're definitely getting marked off. If you only have 1, guess what? You're gonna lose points. So make sure you have all 4, at least. You could have 5 if you want. That's awesome. But you only need to have 4, but you have to have those 4. So listing out what those points are. Don't just draw me this line. I don't want to just see this line. I want to know that you know what the points are that lie on this line. So like 1 point would be right here, which is 2, 1. Let me mark that in another color. So this point right here, that's the point 2, 1. Okay? So that point would be a possible location for the center of rotation. This point right here, 3, 2, that's a possible center of rotation. This point, 4, 3, that's another one. 5, 4, that's another one. 6, 5, so on and so forth along there. So you have to actually tell me the ordered pair. Don't just mark the points with dots like I did. You can write them down. It'll be a lot easier for you than it is for me right now, okay? But that's what you're looking at doing. So figuring out the slope between these two lines, figuring out the opposite reciprocal of that. So remember, opposite reciprocal just means if it was positive, now it's negative. If it was negative, now it's positive. And if it's a fraction, you flip it. And if it was a whole number, now it's going to be 1 over that whole number. Okay? So same thing for 9 and 10. Then for, all over the place. Sorry. Hard to move on this one. I don't know why. For the next point you're taking and you have figures. So the last section was all just points. Now you have actual figures and you have to take and figure out where the center of rotation is here. So if we look at our triangle ABC here and our triangle A prime, B prime, C prime here, and we look for corresponding points. So we've got this lovely little point right here, and the corresponding point is right here. So find what makes a right angle. That's one way to take and do this. So if we extend this out and over, this point right here, now we have a right triangle, or a right angle, I should say. We don't have it closed. What happens when we have a right angle? We have a 90-degree rotation where those two lines, if we drew the lines in, intersect, we'd have a right angle, which means we have a 90-degree rotation, which means that point right there, that lovely point right there, is our center of rotation. So the coordinate of that, if we look across the bottom, there's 5, so we're at 6. There's 6. And then we go up 1, 2, 3, 4. So it's the ordered pair, 6, 4. So same idea for 13 and 14. You're going to be taking and figuring out where is that center of rotation. So just like above where you're finding 4 different centers of rotation, for these 3, you only have to find one center of rotation. So you're just looking at figuring out how can I take that original image and rotate it to get to that new image. Okay? All right, and the last section that's going to take you back to younger days of mathematics. Whoops, if I can get it to scroll down there. There we go. Okay, what we're looking at is area and circumference of circles. So that's all we're looking at doing is figuring out the area and circumference of the circle. So here's our area formula. Area equals pi r squared, r representing our radius, and circumference. We have 2 different equations that we can use. So the first one is c equals pi times diameter. So diameter is the full length across the circle. The second one is c equals 2 pi r, where once again, r represents our radius. So if we look at number 15 here, we have our circle, and if we're trying to find the area of it, we only have one equation. Our radius is this segment right here. So it is 5 centimeters. So if we plug that in, A equals pi 5 squared. 5 squared is what? 25. So we've got 25 pi centimeters squared. Now, the beautiful thing with doing circle problems is you don't actually have to multiply the pi through. You can leave your answer in terms of pi because that gives you an exact answer rather than rounding. And if you remember, what did I tell you? Rounding kills people, so don't round. We don't like rounding. Leave it in exact form. So this right here, this would be the answer I expect to see on number 15 there. That's one of the answers. There are 2 because we also have to do circumference. So now we're going to look at circumference. Now, the first equation isn't going to be the most beneficial to us because do we know what the diameter is right off the bat? No. I mean, we could easily solve for it. Double the 5, we'd get 10. Not too bad. But we're going to do the second one, which essentially the exact same thing. So circumference equals 2 pi times 5. 2 times 5 is 10. So we have 10 pi centimeters. So that is our circumference. Once again, you don't actually have to multiply the 10 and the pi together. I don't want to see a big, long, ugly decimal. I want you to leave it in terms of pi. That makes your life so much easier. Trust me. If you don't want to have to write out a whole big, long set of decimals, or you don't want to see that many decimal or places after the decimal on your calculator, then guess what? Leave it in terms of the pi. Life's so much easier. Once again, rounding kills people. So your key word for today, didn't mention it yet, but it is pi. Note, pi is spelled P-I. Don't tell me P-I-E. I don't want to see that. I want the mathematical pi. So pi is your key word for this lesson, all right? We're going to be using a lot of pi here in the coming lessons because we're going to deal a lot with circles and properties of circles. So pi is your key word for this lesson. Now, Also, make sure when you're taking and answering these area and circumference questions, you have a label. So on the area ones, you'll have some units squared. On the circumference ones, those are just how much it is to go around the circle. So those are not going to be squared. It'll just be whatever that unit is. So just like on this area, I have centimeters squared. This one, I just have centimeters. It's not a squared area. It's not a squared distance. It's just how much does it take to go around the outside of the circle? Okay, so that's what you guys are going to be doing. Hopefully you have those equations down. If you didn't already write them down, I will put this up one more time just for those of you to write it down. So area equals pi r squared. Circumference, you have pi times diameter, and circumference equals 2 pi r. All right, so for the next two questions, you are just doing more with area and circumference. You will be answering both questions, so both area and circumference for 16. And then 17, you have the table to fill out. So it's based off of, let me scroll it down for you real quick so you can see that. Ooh, sorry. So we have these three different circles. Notice it tells you what the radius is in each of them. So all you have to do is fill out your area and circumference parts for each one of the circles and then say how do they compare. So what do you notice about these different circles and their area and circumference values? Alrighty? All right. Once again, your key word was pi, just P-I, not P-I-E, not the food, but the mathematical term. Make sure you take and submit that on Canvas. You'll see a place to do so. It will give you points. So if you want to have points and credit for watching this video, I suggest you do it. If you do not submit that to me, it will be a 0. No ifs, ands, or buts about it. So make sure you take and do that. If you have any questions, I do have office hours Monday, Wednesday, Friday from 1 to 2. So feel free to get a hold of me then. I'll try to answer any questions you have. Otherwise, good luck, and I hope all goes well. Well done.